So today I'm in office, and this is the office setup. So let us start with last class. What are you asking? Today probably I will not be able to teach two classes because we have a limited meeting after 10 o'clock. So for that I have to rush. Anyway, let us start with where we ended yesterday. So we were discussing what is GIS. GIS stands for Geographic Information System. This is like any other information system except the fact that the user can get information related to the location of a particular object of interest. Like any other information system, this also has or should have the capability of capturing, at the same time managing, analyzing, and displaying all forms of information which includes the geographically referenced information. So normally the geographical reference means uh, your location in terms of the established coordinate systems. So what are the coordinate systems means? In terms of x and y. For example, if I may, just give me one moment, take out the paint brush, a little bit describe maybe coordinate system. Okay, so as you can see, this is a coordinate system. So this is a two-dimensional coordinate system where we have the y-axis like this, and we can have the x-axis like this. So suppose you were situated somewhere here on the screen, and this is my origin. This is my origin. Means you can say this is the 0, 0 point. Okay, which point? This point. So if I want to describe your location in terms of this coordinate system or coordinate reference system, then I have to say that if I take some of the usual units, that means I have to go 1, 2, 3, 4, 5 unit along x-axis, and then I need to go down 4 units. So the position of this point according to this coordinate reference system or CRS is how much? 5, 4. It means along the x-axis we will have to go 5 units. So these units may be either in meter, or it may be kilometer, or it may be centimeter, or it may be Armstrong, it may be light year, whatever. So this may be in terms of 5, these particular units, 5 and 4. So suppose I want to describe another point here. So this is point number A, this is point number B. So what is the location of the point number B according to this coordinate reference system? So we have to look into the graph. So according to the graph, along the x-axis I have to come 2 units, and then along the y-axis I have to come 1, 2 units. So again, the location of this point B is 2, 2. So this may be one of the coordinate reference systems, but the same coordinate reference systems if you use to describe your location on the surface of the earth, that can be an input to GIS or Geographical Reference System. But the problem now is that unlike the two-dimensional surface, our earth is not actually Oh, sorry, I was muted. Oh, fuck. Can you hear me now?
Can hear you.
Yes, yes. Okay. Okay, sorry for that. So I'll just take off that speaker. Uh, okay, so we were describing what is a coordinate reference system. Because why we need a coordinate reference system? With the help of the coordinate reference system, you can describe your location on the point of R. For example, if this is my location, this point P, remember we have a three-dimensional space in the physical world. That means we have our length, we have our breadth, as well as we have depth or thickness. So this is the R, this round sphere. So you are somewhere here, suppose this point P. So you can either describe your position uh, by a reference system, which is shown as this one. This is X, Y, and Z axis in this way, and then this is my point of origin. So if this is my point of origin, in order to find me, how much I have to travel along the x-axis. So this is represented by this amount. Okay, let me put it in red color. So this much. How much I have to come along the y-axis. So this much. And then how much I have to go in the z-axis. So around this much. So these values will be x1, y1, and z1. These are the variables. So this can be any value. So if you find these values, so you can actually pinpoint my location on the surface of the earth. So accordingly, it can be a coordinate reference system. Which one? This y, z with the origin this much. This can be a coordinate reference system, or known as CRS, coordinate reference system. Okay, this is well understood. But practically, when we want to describe our location on the point on the surface of the earth, we normally stick to two different kinds of coordinate reference system. One is, let me again explain it. One is known as a three-dimensional coordinate reference system. Sorry, let me start with the 2D one. So one is the two-dimensional coordinate reference system. Another one is the three-dimensional coordinate reference system. So what happens in a two-dimensional coordinate reference system? So normally in a two-dimensional coordinate reference system, we have to project our location onto a two-dimensional space. So suppose this is the art, and then you are somewhere here. Okay? So this is suppose your point. This is P. So normally in order to represent your position on the surface of the art, we will assume a cylinder to be wrapped around the art. Okay? So this is suppose a cylindrical surface, this one. And then this is wrapped around the art. And then we will normally project this point P onto the surface of this cylinder. And then what will happen? When you open up the surface, then if this was my origin, then I will get a point somewhere here. I will get a point somewhere here. So this is my P point. Okay. So this is also known as a projected PROJECTED, projected reference system. This is my origin 0, 0, 0, 0. So if you can have your origin here, then you can calculate how much you have to come this way and how much you have to go this way. You can have your x and y. Okay. So if you can find your x and y, you can find the position here. So this is normally the two-dimensional coordinate system or the projected coordinate reference system. This is also known as UTM, Universal Transverse Marketer, or TM. So this has got different names according to the kind of projection system somebody has adopted. If this is a cylinder, it may be a different projection system. If this is a cone, it may be a different projection system. So normally this will give your projection or location in terms of x and y, and these will be some big values. Okay. So let's now come to the three-dimensional coordinate reference system. So normally when you talk about the three-dimensional coordinate reference system, suppose you are standing here on the surface of the earth, so this is your point P. We assume our center or the origin to be somewhere in the middle of the earth. Okay, so this is my 0, 0, 0 point. So in order to define your location here, we normally use the degree, how much degree you have to come from this axis of, this is my x-axis, along the x-axis, around this much. Okay, so this is known as latitude. How much you have to come this way, and then again, how much degree you have to come along the y-axis or the z-axis. So this will be the longitude. So this will be my latitude will be given in terms of degrees. Suppose this is 26.52 degree, and my longitude will be 91.35 degrees. So this is valid for somebody who is in Assam. So this much from the center, how much degree you have to come either clockwise or anti-clockwise, that will be your latitude. And how many degrees you have to come along the y-axis or z-axis. So these two values will guide your location. So this will be your latitude or longitude. So this is a three-dimensional coordinate reference system where we do not really project your position onto a flat surface, but here you project your location onto, suppose, the surface of a cylinder or a cone, and then we open the cylinder or the cone. Okay, so this is the basic difference. So this is normally some people who will be interested to study GIS or geography probably it's more important for them. But for you also, you should know what these two things are. Okay. So as I said, GIS is geographical information system. This is any other systems, but with the information of the location or this is geographical reference. How do you reference it geographically? Either by a two-dimensional coordinate reference system or by a three-dimensional coordinate reference system. Okay. So it should be able to capture data, it should be able to manage, analyze, and display. So what are these things? We have explained it in the last class. Okay, let me share the attendance now. This is the link for the attendance. Huh? Okay. So, as I said, the GIS is a very powerful tool. Why? Because with the help of GIS, you can analyze different scenarios. And at the same time, this is a very new subject. So, probably since 1970s later, this is opening up for the civilian purpose. So the first GIS software which was open for civilian purpose is known as the GRASS GIS, GRASS, which was initially developed by US Army Corps of Engineers. Okay. So nowadays this is also available, so you can just go to Google and then type GRASS GIS. Okay, I'll just show you here, just for your information, if I may. GRASS, GRASS GIS. Okay, so this is the site. So GraphGIS is initially developed by United States Army. Now it is open for civilian purpose. This is an open source GIS platform. That means you can contribute, you can use without paying any money. So it has got its application for both Linux and Windows and then Apple computers. So this is the latest release, GraphGIS 7.8.4. Okay, so you can see that using GraphGIS, you can do all those things that GIS should be able to do. That means capture, not only capture, but manipulate, analyze, and display information. Okay. Hmm. So since GraphGIS, we have come a long way, and nowadays we have got better GIS software, better in the sense which is more user friendly. So, for example, you have got ArcGIS, then we have got Saga, we have got QGIS, and many more. Okay, so eventually you will have to really dirty your hands with one of these softwares, which I will ask you to download and then install it in your own machines. Okay, probably in the next class. So, what GIS can do? It says the GIS data represents real world objects. So, if you have some streets, if you have some houses, if you have an elevation, if you have certain land use means how the land is being used. Is it an agricultural land? Is it is it a urban land, or is it the water body, or is there some industrial estate? So these all can be represented in GIS. So another thing is that how about the elevation of the area? Is it too high? Is it too flat? What are the actual values from certain data? So all these things can be given an input as certain um, data models in GIS, and eventually you can play with these different layers or different models and then come up with some strong decision support. Okay, strong decision support means it enhances your ability to take very efficient decisions. For example, if you are take an example of the politicians. Politicians, suppose now the election is coming, right? So this may be an application of GIS in social science background, or I would say not a very science background. So nowadays, the MLAs or the MPs, they do have a lot of money in their hand. And then, since the election is coming, probably they would be interested to spend the money in the most efficient way. In the most efficient way means their turnouts maybe they will have their own interests so that they will see a lot of benefits from which constituency or which particular area. If they spend that money, they will see a good return in terms of their votes. So the GIS actually can be very useful in really telling them, okay, so you have to invest in this constituency, in this particular projects, so that you get the maximum return. The return means you get the maximum favor of the common people. So the other way maybe if you have a school you want to open, so which would be the perfect location for a school? So you have a lot of land probably which is near to the street, or somebody has a land which is near to the street. He or she is willing to open up a school, so which may be the best location. Similarly, which may be a location where somebody wants to open up a restaurant. Yeah. So these all will be examples of GIS. Again, when you are using the Uber service with your mobile app, so normally you look for the vehicles which are closest to you. This is a typical example of a neighborhood analysis. So depending on your location, the software or the Uber software, which will be just an Android version that will be installed in your mobile phone, it will be able to allow you to tell which are the 3 4 vehicles which is actually near to you, and then give you the options. Okay, so this is actual example of a GIS software. Again, at the same time, when you are driving, many people use the Google Map service. So the Google Map normally allows you to give you the shortest route. So if you want to go from Panikati area up to the downtown or maybe somewhere in Open Bazaar, so depending on the condition of the road nowadays, which road should I take? That means if I want to avoid the traffic or if there are other criteria that I want to fulfill, which road should I be taking? So these are all very efficient decisions, which is possible with the help of many of the GIS software. Nowadays, GIS software are really very advanced. You even don't know, but you are using the service. So at the same time, if you open up a Uber service and then you are asking for, or not Uber, if you are opening up a Google Map and then you want to explore, suppose you want to go out to a Chinese restaurant, then you are in the middle of some place in Guwahati or some major city, then you don't know really the place, but you really want to explore some of the food, Chinese food, or maybe some continental food. So you just ask your laptop or you maybe just ask your Android phone or whatever phone you have in hand. So this is my location. Please give me the available restaurants within 2 kilometer radius where I am situated. So if you just make this query, this will be this will come under analysis. So the GIS software should be able to analyze whatever query that you ask to the computer or even in your this small machine. This is a computer now. So if you ask this query, then the machine or the software should be able to tell you, and then ultimately they should be analyzing this query, and then they will be giving you results, and this will come under display. So they will display 4 or 5 restaurants, whichever is accordingly meeting your criteria. Okay, and then it is upon your choice where you want to go. Okay, so this helps your efficient decision making. Okay, so broadly speaking, you will encounter plenty and plenty of examples. Even this class is not enough to just cite all the examples that GIS probably can be used nowadays. So in order to do this kind of a query, we'll have to play with 2 kinds of data models. So data model means the moment you want to enter this information into the GIS software. Because if you say, okay, I am located here, how will the software understand? It will be in terms of some location, right? So how will you give this location information into the software? This will be kind of data management. So normally the kind of data that the GIS software understands falls into 2 categories. One is known as the vector data, another one is the raster data. So we have actually described what is a raster data or raster data model. So did you remember the example of the zebra here? Okay. So look at this example, the zebra. So this is a typical example of a raster data. Why should I be calling it raster data? Because the element of this data or element of this uh, picture is this small square box which is known as the pixels. So this is within this box you will have only one information all across the boundary of the box. But the moment you cross from one boundary to another, then this information or this value will change. So this is known as a gridded information. Why gridded? So just look at the example where you were standing with uh, look at the floor. Sometimes many people they have the floor that is made up of tiles nowadays. Okay, so just like the tiles, one piece of tile. So one piece of tile is one pixel. So within that pixel you have one information, one average value. The next pixel is another tile. So the moment you cross it, boundary of one pixel to another, or you jump from one pixel to another, this value changes. But within the pixel, this value remains the same. This is like you were dealing with some grids, okay, with some columns and some rows. So this is the basis of this model. So this is known as the raster model. Normally, when you give input of a satellite image or any image, it is normally a raster image or a raster model. So remember the raster model, they do have this pixel which has got a physical dimension. This another kind of model is known as the vector model. So vector model is different from the raster model in the sense vector model can be categorized again into three subcategories, which is known as point, line, and polygon. So what is a point, line, polygon? This slide will be easier for me to make you understand. So suppose these red dots that you see, these are the hydrant. So hydrant means when you want to extinguish a fire. Remember, normally you have a hose pipe which is attached to a hydrant. Okay, this should be a typical safety features which should be installed normally across the streets. But we don't really see these things in our countries. But maybe you can take it as an example, like these are some of the villages. Okay, so if you want to pinpoint the location of a village or your own location in the computer, it can be represented by one point. So this point is an example of a vector model. So vector models are three types of vector models are there: the point, the line, and the polygon. So what can you store in the point? So if you have a point data, you can store your location. Is it? Can you hear me?
Sir,
I am audible.
sir, you're audible.
Okay,
Yes,
okay.
sir, you're audible.
Okay, so we are discussing what is a vector data type. So there are three kinds of vector data type: point, lines, and polygons. So point is just a point. So if I want to really describe what a point is, can you really describe what a point is in mathematical terms? What is a point? Can anyone tell? How do we define a point? Those from science background, actually, this is nothing to do with science or art or humanities background, but these are some of the things that we actually learned during our school days. So remember the elementary school mathematics. Okay. So if you want to describe a point, what is the definition of a point? Anybody? You come forward. What is the definition of a point? Can you define a line? What is a polygon? Hmm. There may be students from science background here, is it? What is the point? Okay, just I am trying to little bit brush up whatever you may have learned during your school days. So I still remember this was a question that we were asked when I was in my maybe seventh grade. So we had our mathematics teacher. I studied in a government school in Jorhat Government Boys School. We were lucky to have very, how to say, like very good teachers during that point of time. This was my SMS medium school. So the teacher came and then asked, so can you define a point? So there was one particular student who stood up and then he said, point is an entity which has only existence but no dimension. Okay? So this is very philosophical in a way. So can you imagine something which has only an existence but no dimension? You cannot really imagine. Means if I want to place this bottle somewhere here, it will occupy a space, right? If I want to describe the bottle, I can describe it in terms of the physical shape that it occupies. But point is that infinitesimally small thing, beyond that you cannot really imagine anything. So this is the limit of the physical dimension where you don't have really the dimension, but you have only the existence. So if you want to really have an existence, you must have a dimension. This is a regular concept. But point violates that concept. So point is something which only has the existence but no physical dimension. So that means that is the limit of infinitely smaller object that someone can imagine, that is scope. So actually we cannot really draw a point, but we can represent the point. So that is what we are doing here. These red dots are the representation of points. So the moment I put this red dot, it occupies a space which violates the definition or the very basic definition of point. But we cannot help. We cannot really draw a point. We can represent a point only. So the vector model actually makes use of this point as one of their data models. So in point, you can store the location. That means if I have a point, I can say that the point occupies a space of latitude this much and longitude this much. So that may be my location. That may be somebody else's location. Okay, so in GIS, vector model is one of the vector models is the point. Okay, it may be the location of a village, it may be the location of a pond, it may be the location of a tree, maybe building. That depends how you want to represent that particular object on the surface of the earth. The next thing the vector model can handle or the GIS can handle within the vector data model is the line or the polyline. So here also you see some of the lines there. Like this is a line. So these lines are the representations, or they are supposed to represent here are the streets, or this may be the rivers. This may be any of the linear features that you come across in normal day-to-day life. Okay. So what information the line can store? If the point can store an information of location, the line can store the information of a length. You want to know what is the distance from your home up to the university. So you draw a line and then you calculate how long the line is. Yeah? So the line can store this information of distance or length. Plus, the line can also store the information of the direction. So if I want to really describe my house, either if it is on the left hand side of the road or right hand side of the road, this information can also be stored if I have a line. Understood? Yes or no? Eh? Then comes the polygon. So what is a polygon? This is a confined space. I want to draw a polygon here. Okay, so see, this is a point. What I can store? I can store my locational information. I can store the latitude and longitude. I have a line. If I have a line, I have a distance. L is 35 meters, suppose. Or the left side or the right side of this. I have a house here. I can say that it is on the left side of the line if I'm in this direction. The third kind of information or the data model the vector can handle is a polygon. The polygon is a confined space. So if you have a land parcel, that means if you have your piece of land, you want to know how much is the land in terms of square meter or in terms of bighas or in terms of lesas. So you'll have to draw a polygon first, and it has to be a confined space. So the moment you have a polygon in your hand, you can tell what is, or you can calculate how much is the area, right? I can say this area is 425 square meters, suppose. So this information can be stored by a polygon data model or a kind of data model or vector data model which is a polygon. So basically if we have these three kinds of data models, either point, line or polygon, we can do or we can store a lot of information. So remember in GIS you will have to first store this information. You'll have to manage this data somehow. First you have to feed this information into the model onto the computer. So with the help of point, line, polygon, under the vector data model, you can feed this information. Second type of information, as I said, this will be the gridded information or the images. So these images will be like this. They will have some regular grids. So these are the pixels. Pixels. So pixels they represent, in case of a satellite image, they represent three different kinds of energy. As I said, reflected energy, emitted energy, and scattered energy. And then it is an averaged value within this house or within this square block. Okay. So we'll have to end our meeting. These are the typical data models that almost all the GIS softwares they make use of. Okay, and yes. So from the next class, let us try to explore some of these different models. Then later on, we will be entering these analysis of images with the help of these softwares. So I will, within this week, I will give you a thread from where you can download this software, and then first you can install the software in your own laptops. Then I will show you how and where in the internet these images are already available. You can download, and then you can see these information band by band. As I said, satellite informations they capture according to the bands. Remember the spectral uh, resolution. Band number one has a spectral resolution for lengths at 0.42 to 0.45 micrometer. So this is one band. Then there is another band which stores the same information but according to a different band. So these all the bands, about 8 or 7 bands, they capture the same information. So this will be very interesting to see. And then how you can make use of this information for disaster management. This is our ultimate goal. But first of all, we'll have to first install the software and we'll have to understand what are the different data models, like the one that I told you today, and then how you can familiarize yourself with the software. So that means which button you have to click, or which command actually you are executing, these kind of things you have to understand first. Okay. So for time being, I'm not going to take the second class today because I have to rush for a meeting. Then we meet in the next week. Okay. See you. Any questions so far? Please. Do you have any questions? No question?
Sir, I'm a bit confused with the
Okay,
calculations, sir.
that's fine. If you have any question, please feel free to ask. Maybe you can ask in the WhatsApp group. Okay?
Okay, sir.
So don't fear to ask questions. Okay? You may, I mean, by this time you should have a lot of questions actually. Yeah. Okay, see you in the next week.